Good morning guys, and welcome to the next video of the medical concours physics part, and we'll be treating 2018. Yes, the concours of 2018. And before we continue, please, I will ask you people to kindly subscribe. Yes, so thank you. And before we continue, the directions on how we will proceed is listed as follow. So the yellow color, if you see this color, it represents the question. The white color will represent some notes and calculations that will help us to have the final answer. And the red color should be well noted. Yes, the same thing as boxed formulae. They should be well noted. Yes, because those are the key points in the text. The blue color represents the answer. Yes, take note of it. And on this, I wish you people bon appetit. So let's start. Question 1. Two electric charges of -6 microcoulomb and +6 microcoulomb are placed respectively in 2 points A and B, distance of 1 meter apart. The electric field is null at the point C. What is that point C? The solution. Given two opposite charges of the same magnitude, the electric field is null at no point C of the line segment AB. You should take note of that. This is because like charges of same magnitude will always attract to each other according to the fundamental law of electrostatics, which states that like charges repel and unlike charges attract. But for two opposite charges and different magnitude, the electric field is null outside the two charges and near the lesser magnitude charge. For two different charges of the same magnitude, the electric field is null between the two charges and respectively towards the lesser magnitude charge. If they are of the same magnitude, this point is in the middle. Hence, the answer is E. Question 2. A generator of electromotive force 24 volts supplies a circuit having in series a motor of 18 volts and 7.5 ohm and an incandescent lamp of 3 ohm. The intensity of the current in the circuit is 0.5 amperes. The value of the internal resistance of the generator is our solution. So in series, we have a generator, a motor, and a lamp. And we know that from E, which is equals to V plus IR, where E is the EMF, V is the potential difference to the circuit, I the current, and R the internal resistance, then we get 24 is equal to 7.5 times 0.5 plus 3 times 0.5 plus 0.5 times R. Hence, our R is equal to 37.5 ohm. So our answer is B. You should take note of that boxed formula. E is equal to V plus IR. That's the key point there. Question 3. An electric motor operating with a voltage of 120 volts provides a mechanical power of 200 watts. This motor, which is crossed by a current of 2.5 ampere, has an EMF. Our solution, the power P is equal to the potential difference times the current I. Therefore, V is equal to P divided by I. So V is equal to 240 divided by 2.5, giving us V to be 96 volts. Hence, our answer is C. Question 4. In a parallel plate capacitor, an electric field vector, that's our question. The solution, so we see that in a parallel plate capacitor, the electric field vector is perpendicular to the plate the electric field vector is perpendicular to the plate, take note, and it is not parallel to it. From that diagram, we see that the red lines are perpendicular to the two plates. Yes. We also see that it is directed from the positive plate towards the negatively charged plate. So it is in the direction of decreasing potential and not increasing potential. So just for note, the capacitance of a capacitor is equal to epsilon times the area divided by the distance between the two plates. Hence, our answer in this case is A. Question 5. Calculate the impedance of a coil of resistance 10 ohm and inductance 59 microhenry supplied by a sinusoidal voltage of frequency 50 Hz. Solution. Given a resistor of resistance R and a coil of inductance L, the impedance Z is defined as the opposition that an electronic component or circuit offers to alternating or direct current. So these electronic components can either be inductors, capacitors, or resistors as we saw here, or a combination of the three in a circuit. Hence, Z is equal to the square root of R squared plus omega L all that squared, where omega is equal to 2 pi f. F here represents the frequency. So Z is equal to the square root of 10 squared plus, in bracket, 2 pi times 50 times 59 times 10 to the minus 3, all that squared. Z will be equal to 21.06 ohms, giving an answer of D, none of the above. Question 6. The induced EMF in a coil of negligible resistance has a value of 4.5 microvolts. What is the value of the voltage at the end of this coil? Solution. We see that this question is similar to our previous video for 2021. Yes, and we saw that from the diagram below, it is seen that since the coil has a negligible resistance, the value of the voltage at the ends of it is still 4.5 microvolts. Hence, our answer is D. Question 7. 314 meters of an isolated copper wire of radius 1 millimeters is wound in turns around a cylindrical nucleus of diameter 10 centimeters. The number of turns of the solenoid is Solution. This same question repeated itself in 2021, sorry. So we have an isolated copper wire which is wounded around a cylindrical nucleus of diameter 10 centimeters. The cross-sectional view is given as follows. So we see the cross-sectional view there. So the length of the copper L is equal to the number of turns times the circumference of one circle. But the length of the copper wire is 314 meters, and the circumference of a circle is equal to 2 pi times the big R plus the small r. And hence 314 is equal to n, which is the number of turns, times 2 pi into 5.2 times 10 to the minus 2. So n is equal to 961.5 turns, approximately 100 turns. So the answer is C. Question 8. A domestic iron of 220 volt and 1000 watts functioning without interruption from 4 p.m. to 6:30 p.m. consumes electrical energy of Solution. The power is given by P is equal to IV, but electrical energy E is equal to power P times time. E is equal to VIT or Vth, which is equal to I square RT. So you should take note of the boxed formula. The time taken T is equal to 6:30 p.m. minus 4 p.m. which corresponds to 2.5 hours. So T will be equal to 2.5 times 3,600, which gives us 9,000 seconds. So make sure you convert all the units in their SI units. And hence, E is equal to 1,000 times 9,000, giving us an electrical energy of 9 times 10 to the 6 joules. Hence, the answer is B. Question 9. If the atomic nucleus 23390 thorium emits beta particle, the resultant nucleus will contain solution. When a nucleus emits a beta particle, so that's the formula of a beta particle, we see that it corresponds to an electron. The atomic number of the daughter nuclei increases by 1 and the mass number remains the same. So the reaction for disintegration is 23390 thorium, which will give us 233 and instead 91 daughter nucleus plus a beta particle. So we see that the atomic number has increased by 1, but the mass number remained the same. When a nucleus emits an alpha particle, which is a positive helium nuclei, for the daughter nuclei, the atomic number reduces by 2 and the mass number reduces by 4. In the same way, when a nucleus emits a gamma particle, for the daughter nuclei, the atomic number remains the same and the mass number remains the same. Hence, our answer is E. Question 10. The corpuscular character of light is highlighted by solution. In optics, the corpuscular character of light states that light is made up of small discrete particles called corpuscles, in bracket little particles, which travel in a straight line with a finite velocity. Therefore, by the corpuscular character of light, the phenomenon that can explain it is refraction, which is a sudden change in the direction of light waves when they pass one optical medium to another. In the diagram, you can see that incident corpuscles in the rarer medium enter the denser medium and are refracted towards the normal. So, this experiment highlights the corpuscular character of light. Hence, the answer is thus C. Question 11. For a given photoemissive cell, which of the following options is correct? So there is not enough space for me to state out the options. But solution. The threshold frequency depends on the cathode metal and does not depend on the anode nor the number of photons arriving the cathode per unit time. You should take note of that. Visible light and ultraviolet light affect the frequency and hence will affect the photoelectric current. Below is an experiment to better understand the photoelectric effect. So we have the incident light which strikes the cathode or the target metal, causing it to release electrons which goes through the anode. From the anode, there is an ammeter that will read the current through it, and the voltmeter too will notice an increase in voltage. Question 12. What is the mode of disintegration of a carbon-14 nucleus? Solution. Carbon-14 disintegrates by the emission of a beta particle, causing a transmutation in nitrogen-14. So when a carbon-14 nuclei emits a beta particle, it changes into a nitrogen-14 nucleus. Radiocarbon dating in bracket carbon dating is a method for determining the age of an object containing organic material by using the properties of the radioactive carbon-14. So the answer is A. Question 13. What are the values in nanometers of the wavelength limiting the visible parts of the electromagnetic spectrum? Our solution. The electromagnetic spectrum is a spectrum consisting of 7 types of waves. The table below summarizes these waves with their respective approximate wavelengths, and the acronym rad-min-log-sga can be used to remember all the waves in terms of decreasing wavelength or increasing frequency. So to my left, I have the radiation type, and to my right, I have the wavelength in meters. So gamma rays have wavelength of less than 10 to the minus 11 meters. X-rays, the range is between 10 to the minus 11 and 10 to the minus 9. Ultraviolet rays is between 10 to the minus 9 and 10 to the minus 7. Visible light is between 10 to the minus 7 and 10 to the minus 6. Precisely 318 nanometers and 740 nanometers. Infrared 10 to the minus 6 and 10 to the minus 4. Microwaves are between 10 to the minus 4 and 10 to the minus 1, while radio waves have wavelength greater than 10 to the minus 1 meters. So from the table, we can conclude that our answer is A. Question 14. Radioactivity of an element is influenced by. Solution. Discovered by Antoine Henri Becquerel. Reason why 1 becquerel corresponds to 1 disintegration per second. You should take note of that. Radioactivity is the spontaneous and random disintegration of a large unstable nuclei to a small and stable one by the release of an alpha, beta, or gamma particle, or an emission of all the 3 particles. The activity of an radioactive source is independent of physical conditions and chemical bonding, but depends only on the type of the atoms present and the number of atoms involved. So you should take note that radioactivity is a spontaneous and random process that does not depend on the physical condition nor the chemical bonding, but it only depends on the number of atoms involved or the atoms present. Therefore, there are 3 types of radioactivity which may be natural in bracket, during which it is self-induced, or artificial, during which it is a radioactive process as a result of the bombardment with a fast-moving radioactive particle such as a neutron. Hence, from the passage below, we can see that our answer is E. None of the above corresponds to the correct answer. Question 15. Which is not an SI unit? The solution. The International System of Units in bracket SI units consists of base units and derived units. The base units are second, meter, kilogram, ampere, Kelvin, mole, and candela. So those are the 7 fundamental or basic units that you should know. The derived units are, I will just make my best to name some of them. We have the Pascal, Joule, Newton, Watt, Coulomb, Volt, Ohm, Weber, Tesla, etc. And you should take note that you have to know to which quantity they correspond to. You should take note of that. Gallon is not in the SI unit. Full stop. Gallon, along with inch, leg, horsepower, they are not in the SI unit. So the answer is C. Question 16. The origin of Laplace force is. Solution. Laplace force, capital F, is given by F is equals to B cross IL, while Lorentz force is F is equal to B cross QV. Since I, which is a current, originates from charges electrons, and B, which is the magnetic field density, originates from the magnetic field that charges produce when in motion, a combination of the two produces an electromagnetic force known as Laplace force. So Laplace force is an electromagnetic force. From the formula, we see that the force is perpendicular to the current passing through the conductor. It is perpendicular to the length of the conductor and also perpendicular to the magnetic field strength. So to get the direction of the Laplace force, we make use of the Fleming's left hand rule. Take note. So the answer is C. Question 17. In vacuum and in the same region, what happens? Solution. In a vacuum where air resistance is 0, all bodies fall at the same manner. You should take note. Where air resistance is 0, that is in a vacuum, all bodies fall at the same manner. This is because the value of acceleration which causes their falling is a constant value of 9.8 meters per second squared. Hence, you should take note that if a large stone and a small metal bulb are released from the same horizontal level at the same height, the two will reach the ground at the same time. So our answer is E. Question 18. An elevator has a total mass of 1.8 tons, full stop. At the start of the ascending phase, the resistance to displacement is equivalent to 12% of its weight and its acceleration has a value 0.2 g, where g is the acceleration due to gravity and g is equal to 9.78 meters per second square. The magnitude of the attractive force exerted by the cable is solution. So we have our elevator, which represents a rectangle. We have the weight of the elevator W. We have the attractive force F. We have R, which represents the resistance to the motion, and we have a double arrow A, which represents the acceleration or the direction in which the elevator moves. From Newton's second law, we have that the sum of the external forces acting on a body is equal to mass times the acceleration. So the force, the attractive force minus the resistance force R minus the weight W is equal to MA. Hence, F is equal to M into A plus G plus R. Putting the values gives us F to be equal to all those numbers, and we have that F is equal to 23,237.28 Newton, which is approximately equal to 23.24 times 10 to the 3 Newton. So that's why our answer is A. Question 19. Two steel balls B1 and B2 are allowed to fall from the same horizontal plane at a height of 25 meters to the ground. At the initial moment, B1 is released without speed, whereas B2 is launched with a horizontal speed of 5 meters per second. At t equals to 1.5 seconds, what happens? Solution. The height of B1 will be H1 will be equal to gt squared divided by 2 since it is allowed vertically. Hence, 9.8 times 1.5 all that square divided by 2 is equal to 11.025 meters. The height of B2, H2, will also be 11.025 meters. This is because after 1.5 seconds, both balls will have the same height. Both balls will have the same height from the point of release. B2's height is the same as that of B1 because when projected with an horizontal speed, that does not affect the initial vertical speed. And in this case, it is 0 meters per second. Hence, while falling, it will take a parabolic path because while falling, it will develop a vertical velocity and an horizontal velocity. The magnitude of their speeds are not the same. You should take note. The magnitude of their speeds are not the same because after that time, the speed of B1 will be V equals to 14.7 meters per second, and I got it from V equal to U plus GT. In this case, U equals 0. And that of B2 will be V equals to 16.4 meters per second. That is gotten from V vertical equal to U plus GT and V horizontal, which is equal to H square divided by T. It's left as exercise for you people to calculate. Hence, our answer is C. Question 20. The work done by a force perpendicular to displacement is solution. Work done is equal to force dot displacement. Hence, W is equal to F equals theta, where theta is the angle between the force and the displacement. So if the force is perpendicular to the displacement, that is theta equals to 90 degrees, then the W will be equal to F equals 90, which is 0 Newton meter, hence null. In the same way, if it was moment is equal to force cross displacement, hence moment is equal to Fd sine theta. So if the force is parallel to the displacement, that is theta equals to 0 degrees or theta equals 180 degrees, then the moment is Fd sine 0, which is equal to Fd sine 180, which is equal to 0 Newton meters. After all this, the answer is C. So the work done is null. Question 21. A ball is thrown from a point O on the horizontal ground with a speed v0 inclined at an angle alpha with respect to the horizontal. Neglecting air resistance and considering the ball to be a point mass, during the motion of the ball, the acceleration vector is solution. So we have the ball which is projected from O with a speed v0 at an angle alpha. It acquires a parabolic path. We see that the acceleration that opposes the motion of the point ball when it goes up is minus g. At the top of the path, the sign of g, that's the acceleration due to gravity, changes from negative to positive, and this causes the particle to start accelerating downward. Hence, our answer is D. Question 22. At the summit of the trajectory, the speed is solution. At the top of the path, the horizontal velocity, that is Vx, is equal to V0 cos alpha, is kept constant. The horizontal velocity is not affected by gravity, it is kept constant. But the vertical velocity is 0 at the top, since the acceleration at the top is 0, and so V which is equal to Vx squared plus Vy squared will be minimal, with V being equal to Vx being equal to V0 cos alpha and Vy being equal to 0. So the speed is minimal and not null. So the answer is C. Question 23. At the summit of the trajectory, the speed is solution. From the equation of trajectory, where we have y equals to x tan theta minus gx squared all over 2v squared into 1 plus tan squared theta, at the top, dy dx is equal to 0. So h max is equal to v0 squared sine square alpha on 2g. So that's the formula for the maximum height. And from the formula, we see that the maximum height is proportional to the square of v0. Our answer is thus D. Question 24. A car moves at a speed of 90 km per hour. To which height should it fall without initial velocity to attain the same speed? Solution. From Newton's third equation of motion, where v squared is equal to u squared plus 2gh, v is the final velocity, u the initial velocity, g the acceleration due to gravity, and h the height. Hence, to fall without initial speed and attain a speed of 90 km per hour, which is equivalent to 25 meters per second under acceleration due to gravity g, in this case it is 10 meters per second square, it must be placed at a height h given by h should be equal to v squared all over 2g, which is equal to 25 squared divided by 2 times 10, which is 31.25 meters. So the height at which it should be put is 31.25 meters. Hence, our answer is C. Question 25. The electrical energy received by a receiver whose terminal voltage is 3 volt when it is traversed by a current of intensity 1 ampere during 20 milliseconds is solution. From E equals to V, E is equals to 3 times 1 times 20 times 10 to the minus 3. So E is equals to 0.06 joules, which is equivalent to 6 times 10 to the minus 2 joules. Hence, our answer is C. Thank you for watching the video, and make sure you really study it well. Thank you, and see you in another video.